Hey guys, welcome back to my channel. Single phase full wave AC controller with RL load. Today we'll learn about this controller where the load is R and L in series with each other. L is an inductor and R is a resistor. Okay, so and this Vs, which is source voltage, with value Vm sin omega t, where Vm is the highest value of this source voltage, maximum value. Okay, and these two are thyristors T1 and T2, and V0 output voltage across this load and output current which will flow through this load. There will be some potential difference across these thyristors. So for T1 it is Vt1 and for T2 it is Vt2. Okay, and both thyristors are connected in anti-parallel to each other. In previous video I have explained why how these two thyristors are connected in anti-parallel. Okay, now let's jump to the wave diagram for this controller circuit so that you can easily understand how it works. So this is wave diagram for this controller. Here the source voltage is Vs, is Ig1, and this is Ig2. Ig1 is the gate current for thyristor T1 and Ig2 is the gate current for thyristor T2. As we know that thyristors need some triggering pulse so that they can starts to conduct. Without triggering there will be no conduction in these thyristors. Okay, and this is I0, the current which will flow through the load, V0, which potential difference which will appear across this load. Okay, and this is Vt1 and Vt2, which are potential difference across each thyristors. And let's consider the first positive half cycle of source voltage. So here you can see until alpha we have triggered the thyristor 1 after at the point of alpha, but before alpha, from 0 to alpha, you can see there is some amount of current which is coming from the negative portion and then goes to 0 value. Okay, and here you can also see that potential difference was also going to positive then at this point, which is known as beta. For now you can ignore this part and this part of both output voltage and output current. Now you can see this that there is some conduction from 0 to pi. There is some current was flowing through the circuit, so the voltage across Vt1, so there is some value, not exactly 0 but very slightly below the 0. From beta to alpha, when there was no conduction was taking place in this circuit, then there will be some potential drop across this thyristors. So let's talk about Vt1 which will be the potential difference across this thyristor T1. So as you can see, for positive half cycle this will be positive and this will be negative. Okay, so the T1 among both thyristors, T1 is in forward bias right now. The potential difference across T1 will be in positive in nature and potential difference across this T2 will be in negative. As you can see, there is positive potential difference appear across thyristor T1 and negative voltage appears across the thyristor T2, because T2 is reverse bias for now, for only positive half cycle. After giving triggering pulse to this thyristor 1, current starts to flow in the circuit. As after triggering it starts to conduct. Okay, so current will increase and from to the point where voltage source is 0 but current did not reach the 0 value. Okay, why it didn't go to 0, I'll explain you. And potential drop also goes to 0 with this voltage source. Okay, now why this happened, why the current didn't go to 0 directly? This happened because of this inductor we have added in the circuit. What inductor does, it stores the charge. Okay, so when the current was flowing through it, it started to store some charge, and after, when the source voltage is 0, it means from here we get 0 value, this inductor discharge itself. Okay, so here when the value of output current was maximum, the value of source voltage was 0, but due to inductor there was some current remaining in the circuit, so It should be 0, but it didn't go to 0 because there is an inductor in this circuit which stores the charge, and then when there is no current flowing from the source voltage, it will start to discharge itself. So now after this point, this inductor will starts to discharge itself, so there will also flow through the circuit. And at beta point it totally discharges itself and current value becomes to 0, but there is current flowing through it, so there will also be a potential difference. So now from here potential drop will be go in negative direction, and at the point beta both current and voltage reaches the 0 point. Okay, as we have seen that from alpha to beta there was current flowing through this whole circuit, so that's why we didn't get any potential drop from alpha to beta. But after beta, when both current and potential drop across the load is 0, now we can see the potential difference across the thyristors. Okay, let's come here. Now we'll consider the negative half cycle of this voltage source. So for negative half cycle, during negative half cycle, this A point will be negative and this B point will be in positive. T1 is in now reverse biased because here it is negative and this is positive terminal of the thyristor. So here thyristor T1 is reverse biased and thyristor T2 is in forward biased. Okay, so beta to pi plus alpha, this point is pi plus alpha because 0 to pi and then pi to alpha. It means from 0, if we count from 0, this point will be pi plus alpha. Until pi plus alpha there will be no conduction. Okay, there will be no conduction in circuit because there is no current flowing through the circuit. We can see some potential drop across these thyristors. So now in this case we are considering the negative half cycle of the current. Okay, so we know that this time T1 is in reverse bias and T2 is in forward biased. Okay, so the potential drop will be here, the potential drop will be negative for T1 and for positive for T2. That's why we can see in positive half cycle VT1 was experiencing positive potential difference and VT2 was experiencing negative voltage drop. But now in negative half cycle VT1 is in negative because T1 is reverse bias and VT2 is positive because T2 is in forward biased. Now after pi plus alpha we triggered the T2. Now T2 will starts to conduct after triggering. So here we can see that current starts to flow, and as the current is flowing, inductor is also charging itself. Okay, as you can see here also current didn't go to 0 value as the source voltage is 0 because there is some charge stored in this inductor. So now when the source voltage is 0, this inductor will starts to discharge itself. That's why we can see from 2 pi to beta we can see that the inductor is discharging itself, so there will be current flowing through the circuit, and at beta the L will be discharged completely. But as the current is flowing there should be some potential difference, so this potential difference is now goes to positive in direction, and after beta when current is negative voltage is also negative. Okay, now let's see only this part and this part. Here also this part and this part. As you can see there was some current coming from the negative, so this is the current which was flowing to the positive, first to the 0 and then to the positive. So if we consider a continuous wave, so we can experience this in starting also. So as you can see here and here both cases are similar. We are getting some current from the negative initially and some positive potential drop initially. Okay friends, this is it. Thanks for watching.